Okay, good afternoon. The battery didn't fall, so you sit in the chair. Okay, you already have lesson 15 in your classwork book, and this is how it's going to be working from now on. We'll be following the lesson. So what I need in front of you is your classwork book, and possibly, you know, those funny colored pens, the bright pink, in case you just want to make a small note, or maybe a pencil, a ruler in case you want to underline. But we're going to be looking exactly at the notes that you have written. So please open the notes to lesson 15. Open to lesson 15. Hello. You're not leaving it at all. You need the notes in your classwork book. If it's not there, then that's it. But I don't want to see that. I don't want any distraction. Open your classwork. You don't have lesson 15. Who has lesson 15? Those are the ones who are ready for today. Yeah, that's what I'm following. So, lesson 15. I started by talking about integers. Okay, and we said all the integers. Sorry, the notes are in front of you. Those of you that are at home today, the green group, the notes are in front of you. I wished to project it, but somehow I can't right now. But you have the notes in front of you. Okay, so the integers consist of all the whole numbers, the positive whole numbers, the negative whole numbers, and 0. All of them together. Okay, so the first thing I said there is that since integers are whole numbers, all the properties that I discussed with you in lesson 2 are still true. So the first thing we're going to do now is to go back to lesson 2 and check what are those properties that were discussed in lesson 2. What were those properties that were discussed in lesson 2? The properties of whole numbers that were discussed in lesson 2. What are those properties? Anyone? The properties that were discussed in lesson 2. The properties of whole numbers that were discussed in lesson 2. Nancy? Properties of whole numbers that were discussed in lesson 2. The properties of whole numbers that were discussed in lesson 2. Thank you very much. Commutative property. Okay, let's talk about that quickly. Commutative property simply means that numbers can be moved around in a sum, and the answer is still exactly the same. Numbers can be moved around, and it will still be exactly the same. Now, please take note that in the notes, I've indicated that commutative works with addition and multiplication. I've indicated already in the note. What you need to add is that commutative property still has to obey BODMAS. It still has to fall under BODMAS. And that's why when I write a sum like 3 plus 5 times 7, according to BODMAS, the 7 and the 5 must multiply first. Yeah? So the two numbers that must multiply are 5 and 7. So I can rewrite this sum according to commutative and say 3 plus 7 times 5. Of course, it's still true because the two numbers that are multiplying are still 5 and 7. Now, commutative now says I can even write 5 times 7 plus 3. Actually, I can still write 7 times 5 plus 3. All these four sums mean exactly the same because in each of the sum, the two numbers that multiply are 5 and 7. And after the multiplication, then we add 3, and then we get 38. Are you still here? Okay, so commutative means numbers can be switched around. Are we good? Okay, another property of whole numbers from lesson 2. Pardon? Distributive property. Distributive is like sharing, distributive property. There are many different ways of putting it. My favorite way is to say when a number is placed outside a bracket, it multiplies everything inside the bracket. When a number is placed outside a bracket, it multiplies yonkinto inside the bracket. And so I can talk about a sum like 5 multiplying 2, I said 2, but I wrote 3, 2x plus 3. But I can also say minus 7, like that. And then I need you to understand and to accept that the 5 must multiply the 2x. The 5 must multiply the 3. Now, how about the negative 7? No, because it's now outside the bracket. The operation of 5 ends when you close the bracket. When you close the bracket, then the operation of 5 ends. But 5 outside the bracket there means it's going to multiply. And then another way of putting it is to who watches Oprah Winfrey Show? Who knows Oprah Winfrey Show on TV? These people don't even watch TV. When Oprah gives gifts in the studio, she says, you get one, you get one, you get one, everybody gets one. But you have to be in the studio before you get one. So everybody in the bracket gets one. Okay, that is distributive. One more thing. Means exactly the same. Because what it means is when a 10 is placed outside a bracket. I didn't say in front. When a 10 is placed outside a bracket, it multiplies everything inside the bracket. It could be in front or it could be at the back. Okay, that's distributive. And then another property. Talk to me so the class can move. Associative. Associative just talks about grouping. There are different ways of saying associative. If I say 3 plus 5 plus 7, you can start with the 3 plus 5 and then add 7. Or you can start with the 5 plus 7 and then bring 3 in if the operation is exactly the same. Okay. Also with addition and multiplication. That is the associative property of whole numbers. Okay. Those are the 3 major. The remaining 2 will come back to them just now. But let's go back to today's lesson. Let's go back to lesson 15. So I said all the properties that I discussed in lesson 2 are still true. Is everybody with me? Yeah. All the properties that I discussed in lesson 2 are still true. Okay. And then from there, I go on to talk about a number line. Negative numbers, you have to be very careful. Negative numbers, you have to be very careful. Because a negative number means that this is how we go normally. There is a U-turn. So you have to watch out for negative numbers. Even on your calculator, you will see the negative numbers is put in brackets. So many times when you're working with negative numbers, we use brackets to protect the negative sign. But as we see the sums, I'm sure that you get better. Okay. So I talk about the number line. What's a number line? A number line is a straight line on which all real numbers can be marked. All real numbers can be positioned on the number line. So my next question is, what are real numbers? What are real numbers? Guess what? It's in your classwork book if your notes are there. What are real numbers? How many notes have you written so far? Is it in your classwork book? What are real numbers? All the numbers that exist and are used in mathematical calculations. What lesson is it in? 3. Lesson 3. Real numbers refer to all the numbers that exist. If the number exists, then it is on the number line. It could be rational, it could be irrational, it could be a surd, it could be a fraction, it could be a decimal. So long as it's a real number, it can be shown on the number line. Those of you that are going to do pure math, one of the first things you do at the beginning of grade 10 is to be able to place any number they give you on a number line. Okay, so when I say 0,333333, or when I say 0,187,187, you should be able to know where exactly it falls on the number line. For the rest of us, for instance, you should be able to say on a number line, where is 2,5? Halfway between 2 and 3. Does that make some sense? Yes. Where is 2,5? Halfway between 2 and 3. Like that. Ne? So you should be able to place that on a number line. Now, why is Onikoyi talking about a number line now? Two reasons. When we worked with integers a few years back in grade 9, when we worked with integers, we expected our learners to be able to count, to add on a number line. So the number line can actually be used as a tool for addition and subtraction, working with integers. But these days, we know that you're going to use a calculator. So I'm just teaching you the number line, especially so that you'll be able to number a number line correctly. When we get to graphs, we talk about a Cartesian plane where we plot graphs. We use two number lines that meet at the point 0. That's what it actually is. So how do you number a number line? You have to know where 0 is. Why? According to what I gave you in the note, every number on a number line tells you how far you are from 0. That's number 1, distance, and in which direction. So every number talks about the distance from 0 and the direction from 0. So it means that whatever you are saying has something to do with 0. So the most important thing on your number line is what? 0. So if this is my 0 on the number line, that's positive. And then I turn and I go 1, 2. Where am I now? -2. Because I went in the direction of negative. How many steps? 2. So from 0, positive direction, 1, 2, 3. Where am I? Positive 3. Like that. So every number on a number line has something, is talking about 0. What are the two things? Distance and direction. Okay? So from now on, remember that a number line, I can place it horizontally, like the one in your classwork book, the one in the notes I gave you. You can also place it vertically, like this. You can have a number line like that. The most important point is 0. Traditionally, when we have a line like that, going up is positive, going down is negative. And when we have it horizontally, going right is positive and going left is negative. So when we get to graphs, we're going to place them together such that the 0 of that one is also the 0 of this one. And then we call that point origin. So when you move up, it will be positive 1. When you move this way, it will be positive 1. When you move this way, it will be negative 1. When you move that way, it will be negative 1, like that. Because there are two different lines. It's just that they meet at the point of 0. Okay, so that's a number line. I already said it's a tool for addition and subtraction, but if you really need it, then I will show you how it works. But that is the number line. And then the next thing I talk about in the note is something you've seen before, the rules for multiplication and addition, working with positive numbers and negative numbers. That's in your grade 8 syllabus, I know. But I wanted you to look at it again so that you'll be able to draw the conclusion with me, because I'm going somewhere with this. When you multiply two numbers and their signs are the same, your answer must be positive. When you multiply two numbers and the signs are the same, which means the signs can be positive and positive, or it can be positive and negative. Sorry. Negative and negative. Your answer must be positive. The moment you are working with numbers where the signs are not the same, your answer will be negative. Are you still here? I'm tying it all together. So make sure you don't get lost. Don't let your mind wander, né? Because I'm linking things together now. So if you are multiplying and you're multiplying a number by itself, you are multiplying a number by itself, then your answer will always be positive. I must say that again. Must I say it again? When you multiply two numbers and the signs are exactly the same, your answer must be positive. Whether the two numbers you're multiplying are positive and positive, or they are negative and negative, but your answer must be positive. So when you take a number and you multiply it by itself, your answer must be positive. Why? Because if that number was 5 positive, you say positive 5 times positive 5, the signs are the same, so your answer will be positive 25. Now, if the number is negative 4, you are saying negative 4 multiplied by negative 4 itself, isn't it? Now the signs are the same, so your answer will also be positive. That's why all squares are positive. All squares are positive. But in your note, it says a square root, because square root is not the same as square. Eh? A square root can be positive or negative. I'm going to another page to show that. A square root can be positive or negative. And the example in your classwork book is this one. Now, before today, when I ask you what is the square root of 9, what answer will you give me? Okay, so I'm saying 3 is no longer correct. What's the answer? 3 or negative 3. 3 or negative 3. Kanjani, because when I say 3 and I multiply it by itself, what will it give me? So I'm correct. If I take negative 3 and I multiply it by itself, what will it give me? So both of them qualify. Ne? So the square root of 25 is what? 5. Or. What's the square root of 25?
5 or negative 5.
5 or negative 5. Does it make some sense?
Yes.
Does it make some sense?
Yes.
So a square root can be positive or negative. See, I'm mentioning these things because we are going to use them later. Have you noticed that's what I'm doing? Eh? We are on lesson 15 now. We are going back to lesson 2. So you know that when we get to lesson 25, I will come back to lesson 15. You already see it's going to happen. Eh? We will keep turning back like that to say, remember we said this, because now you have heard it a few times. Okay, so the square root of a number can be positive or negative because both of them will qualify. Ne? 5 times 5 will give me 25. Negative 5 times negative 5 will still give me 25. And what is the square root? The square root, when I ask what is square root, I mean which number did I multiply by itself to give 25? Ne? When I say what is the square root of 25, what am I asking you? Which number do you multiply by itself to give 25? So yes, it is either 5 or negative 5. Okay? Am I good there? Okay, let's go to the next thing. What did I say next? Then I talked about, no, let's talk about those ones they are basically for information and for those ones who are curious. Ne? But take note, I know you're going to use a calculator when it comes out in an exam. Ne? Take note that when you multiply 2 by itself, your answer is positive. When you multiply negative 2 by itself, your answer is still positive. Now, when you take it 3 times and you say 2 times 2 times 2, because it's all positive, your answer is positive. But when you say negative, like that, remember that negative times negative will give us positive. So negative 2 times negative 2 already gives me positive 4. Now that positive 4 multiplied by negative 2, two different signs. Ne? So my answer must be negative. Yeah. So we said this cube root of a negative number will also be negative. Okay. But like I said, I know you're going to use calculator for that. So let's go to additive inverse and multiplicative inverse. That's what I want to talk about quickly. Now, the additive inverse of a number is another number that when you add it to the first number will give you 0. There's something there in lesson 2. Under 0, I highlighted it in the notes. There's something there in lesson 2 that I highlighted in the notes. Something there in lesson 2 that is highlighted in the notes. There's something there in lesson 2 that is highlighted in the notes. Has anyone found it? Have you seen what is relevant to that?
Yes.
Read it. Let me hear.
0 is the identity element of addition.
Thank you. 0 is the identity element of addition. So, why do we say it's the identity element of addition? Okay, no, they can't see. They can't see. The ones at home can't see. Unless I'm using something else to record. Okay. Why do we say 0 is the identity element for addition? Because when you add 0 to a number, what happens? You ne? When you minus 0 from a number, what happens? So we say it is the identity element. Now, AI, additive inverse, is the way to bring a number down to 0. Okay. How do you make a number to become 0? By bringing in the additive inverse. But you see, in your note, Mem gave you the trick to always get it right. What does it say there? In the bracket below the definition, it starts with easy. What did Mem say? Just change the sign. Mem said it's easy, just change the sign. So when I ask you, what is the additive inverse? What is the additive inverse of 5?
Negative 5.
The AI is equal to negative 5. Next, when I ask you what is the additive inverse of negative 11, it will now be positive 11. Just change the sign. When I ask you what is the additive inverse of 0,82, the additive inverse is simply equal to, tell me, negative 0,82. So additive inverse is straightforward. Ne? You just change the sign. And then, how do you know you are correct? Take a calculator and punch them in together. Your answer must be what again? 0, which is what? The identity element for addition. Are you still here? Okay, that's straightforward. That's straightforward. I gave you a few examples. You should have done it, and you would have seen how easy it is. But let's go to MI, multiplicative inverse. Again, what does it say about multiplication in lesson 2? It says what? In lesson 2, 1 is the identity element for multiplication. It was highlighted in the note, so you should have highlighted it. Now, how many of you noticed that I put all the lessons in the new group? Okay. Only 2, 3 people, 4. Okay. I put all of them in the new group. Lessons 1 to 14. Okay, so what are we busy with? Multiplicative inverse. Ne? So remember, we say 1 is the identity element for multiplication. We don't always say elements. Ne? 1 is the identity for multiplication. Okay, 1 is the identity for multiplication. What does that mean? When you multiply a number by 1, what happens? It stays the same. How about when you divide a number by 1? Same. So how do you make a number to become 1? You multiply that number by its MI, its multiplicative inverse. Now at the bottom also in the note, I gave you steps on how to get multiplicative inverse. I said, step 1, what's the first thing you do? Write the number as a fraction. That's step 1. Write the number as a fraction. What if it's a whole number? What if it's a whole number? Is it? All whole numbers are over 1. Because I opened this so that the people at home will hear my voice clearly, I don't even know how to tell you and you to cover your nose, but your noses are supposed to be covered. The mask covers both the nose and the mouth. Okay, but I'm recording this lesson, ne? Just like I will record another lesson tomorrow and post it to you. Hence, I pulled that so that my voice will be a bit clearer. Ne? Okay. Yes, I was saying, first step, according to the notes ma'am gave you, is that you write the number as a fraction. So I said, how about whole numbers? And somebody said, now, remember we can't see your lips, ne? Because it's covered. So express with your eyes. Look at somebody and say, all whole numbers are over 1. Tell somebody. I want to hear your voice. I want to hear all your voices at the same time. It's not loud enough. Your eyes must show what you are saying. I want to see. Huh? What is it? What did you say again? All whole numbers are over 1. So when I ask you for the multiplicative inverse of 5, the first thing I need you to do is to write 5 as a fraction. It's a whole number, so it must be over 1. Next. And then what is the multiplicative inverse of 5 over 1? You turn it upside down. Where's the calculator? So yesterday I was discussing this in the grade 9 class. And then I said, first, step 1, write it as a fraction. And then when it became a fraction, I said, then turn it upside down. And the grade 9 boy that was sitting here just turned it upside down. Turn it upside down like that. Okay. Turn it upside down means invert the fraction. So the FI will be 1 over 5. Are you here? Make sure that's written down in your class workbook. Make sure it's written under today's date. Class workbook, Sissy. Did you write the lesson? Why not? Why didn't you get it? It's been on Google Classroom for about 3 o'clock yesterday. You are in an e-learning school. Huh? E-learning. Let's look at example number 2. What if you have to calculate the multiplicative inverse of 28? Multiplicative inverse of 28. Step 1. What's step 1? Write the number as a fraction. Write the number as a fraction. It's a whole number, né? So what will I write? Tell me. 28 over 1. And then what's the multiplicative inverse? 1 over 28. Are you still here? Okay, please don't rule your classwork book, but I'm going to rule this so that even people at home can keep an eye on what's going on here. Okay, I'm going to rule just because, well, don't rule your book. We write in column, in one column in your classwork book. Okay, my next example. I want the multiplicative inverse of 0.16. I want the multiplicative inverse of 0.16. Step 1. Write the number as a fraction. If you have that calculator, that's Casio FX82. It makes you look smart. Eh? Just punch the number in and say equal to. Don't let anybody know that's what you're doing. Come now, quick. So convert 0.16 to a fraction for me. Hey, I have a class of intelligence people. Oh, how nice. Oh, how nice. They say it's equal to 4 over 25. Eh? then the multiplicative inverse will be equal to Kuluma Nami. Huh? Huh? Just turn it upside down, guys. 25 over 4. Okay, example number 4. I'm just going to introduce something new there. What is the multiplicative inverse of negative 3 over 4? What's our step 1 again? This one is already here. So step 1 is done. What's step 2? Turn it upside down. Is there more? Did I write any more there? Yes. Yes. I wrote 4 things. I started by saying step 1 is write the number as a fraction. Step 2, I said invert. And then the third statement, I said invert means, and then number 4, the fourth statement that I wrote there, I said what? The sign must be the same. All the ones we've been doing, I've given you positive numbers. So the MI is also positive. Manje, my number is negative. So the multiplicative inverse is also negative. The sign of your MI and your original number must be the same. So that when you multiply them, you will get 1, positive 1. Remember, the signs of the numbers must be the same so that when you multiply, you will get 1. Remember, this is multiplicative inverse. Yeah? Okay, so the multiplicative inverse will now be what now? 4 over 3. Okay, that's multiplicative inverse. And that's my lesson for today. Basically, unless you have questions. There's an activity at the end of the work that you are supposed to complete or at least start so that you'll be able to ask specific questions. So that you'll be able to say, but then I tried this one, and it didn't look like it was working. Okay? And remember, don't fight it. This is how it's going to be. I send the notes, write them down. You watch the video if it's your homeschooling day, or you're sitting here if it's your schooling day, and then we'll go to the next one. Okay? So today, you will get lesson 16, and then tomorrow you will get a video. Yeah? Just like I'm recording now. Okay. Okay. Yeah. What else? What else is in the notes that you want to check? I said I can teach you how to use the number line. Is there anything in the notes that I didn't cover, that I didn't talk about? Please check it for me quickly. I know you already know what it is, but yeah, let somebody check for me quickly. Anything in the notes that I didn't mention? Cube roots. I did. Cube roots means which number did you multiply by itself by itself. Take note, if you are starting with a negative number, then your answer will also be negative. And if you're starting with a positive number, your answer will still be positive. And I'm still going to make you write those numbers down at the back of your book, and let's see how many do you know by heart by the end of the year. Okay, I know I'm crazy, it's fine, but I know to a large extent. If you ask me, you have a calculator in front of you. The cube of 1 is 1, of 2 is 8, of 3 is 27, of 4 is 64, of 5 is 125, of 6 is 216, of 7 is 343, of 8 is 512, of 9 is 729, 10 of course is 1,000, of 11 is 1,331, of 12 is 1,728, of 13, oh, I don't know, I forgot. I'm going to make you write those things at the back of your classwork book. All you have to do is look at it. Yeah? You keep looking at it. Remember, you're not calculating, the answers are already there. Yeah? You keep looking at it until you get to a point where it doesn't scare you when you look at it again. For instance, when you get to exponents, you find a number like 243, and sometimes you see the number 343. Now there's a difference between these two numbers. This one is 3 raised to the power 5. This one is 7 raised to the power 3. Ne? So the first time you see such numbers, you must be able to say, I know this number. Ne? And then sometimes you're supposed to factorize a number. You're showing your factorization. You know that number, you recognize it. And this one is either from 3 or from 7, like that, and then it guides you. Okay. You're also supposed to recognize the number 5 when it ends a number. If the number ends with 5, it means it is divisible by 5 once. If it ends with 25, it's divisible by 5 twice. If it ends with, it's divisible by 5 3 times. Like that. Ne. Like that. Anyway, yeah, sounds like I'm boasting. Of course I am, but yeah, ish. On your calculator, say 5 times 5. It says 25. Press equal to, what happens? Just press equal to again. What does it say? Is there a change? No. Oh, okay. How does a calculator do that thing? Where I can tell you 5 raised to power 1 is 5, raised to power 2 is 25, 5 raised to power 3, you have to use answer, ne? You have to use the button answer. Okay. And so anyway, so like, but those are the things that I will make you write at the back of your classwork book so that you get used to these things. But I think that's my lesson for today. I was going to show you how to add and subtract to the number line. So I have my 0. 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6. Okay, like that. Right? So my number line, I can use it to say, when I say 3 minus 2, of course you know the answer. Ne? 3 minus 2 means stand at 3. That's 3, ne? Face which direction now? Negative. And move how many steps? 2. 1, 2. What's the answer? 1. Ne? Yeah, but we used to teach this when I started teaching grade 9. Ne? We don't do that anymore. When I say -5 plus 7, it means stand at -5, face which direction? Positive, and move how many? 1, 2, 3, 4, 5, 6, 7. So that my answer is 2. Like that. No? Okay. Now, when I say something like -3 minus -2, it means start at -3. Ne? Ne? This one says face the negative direction, basically. Normally, when you are writing, listen to your hand is going like this. Ne? So normally when you are standing at -3, you are facing direct, positive. Ne? So negative sign says, ne? Now you are facing negative. But the other negative sign, again. Yeah? Negative sign turns around. So normally, when you stand, where do you face? Forward. Ne? So you are standing at -3. You are facing this side now. This one says turn around. So now you are facing here. Then this one says turn around. Now you are facing here again. Then you count how many steps? 2. So your answer is -1. Ask your calculator. Remember to use that negative sign in the bracket. Let me see. That's what the number line is for. That's my lesson for today.